More people did it, but a lot of you did, so good job. Okay, so remember, it says, given these three solutions, 1, 2, 3, and I want you to notice something. This and this are conjugates. Now, why does that make sense? Because irrational solutions, conjugates have to be solutions, right? If we have three solutions, our final polynomial should be degree 3. So we're working backwards. So we subtract 2, subtract root 3, add root 3, right, to both sides. So you should have an x minus 2, x minus root 3, x plus root 3. Now, how many got that far? Raise your hand. Okay, good. Now, how many of you remembered when multiplying three binomials? Now, remember what a binomial is, two terms. 1, 2, 3 binomials. You should multiply the conjugates together first. Who remembered that? Nice. You were the people who got it right because you did that. So we'd multiply this out. We have x squared plus x root 3 minus x root 3. Right, here's where people mess up. Minus root 9. Am I right? So now look, our middle terms will cancel out. So we have x squared minus 3. And now we'll multiply that to x minus 2. So we would go ahead and distribute x cubed. Am I right? Minus 3x minus 2x squared. And then right here, don't mess it up, plus 6. So in standard form, you should have x cubed minus 2x squared minus 3x plus 6. How many of you got it 100% correct? Nice. Perfect. Okay, great. So now what I want you to do is go on to this next one if you have not already. Erase that. So it says, what is the polynomial in standard form with these given roots? Now in this problem, it's asking you to do the same thing, but there's something that you have to remember without it being told. Can anyone remember what it is? Of what? Yes. Yes, he is right on. Braden's right on. You remembered, if there's an imaginary solution, its conjugate, negative 3i, must also be a solution. Ready, set, go. Work backwards the same way. So, with this one, we're working backwards. We should have an x plus 1, and then from here, an x minus 3i, an x plus 3i. Then from there, you should say, I'm going to multiply the conjugates together. X squared plus 3ix minus 3ix. Right, here's where people usually mess up. Minus 9i squared. Good point. So the middle terms cancel out. You're remembering that I squared equals negative 1. I'm hearing people say. So what we have is this, x squared minus 9. What the heck is going on with my pen? Minus 9i squared, which is x squared minus 9 times negative 1, right? So isn't that x squared plus 9? And now we'll multiply that to x plus 1. You would distribute, and your final answer would be x cubed plus x squared. Okay, awesome. If you made an error, are you at least seeing where you're making your error? Yes or no? A lot of you got it right. Okay, good. Awesome. Okay, erase your whiteboard. Now you can impress me. You have the chance to impress me again. So this is what we learned last time. So everybody think about it. We learned last time that all functions that are shifted from a parent function, we can verbally describe the shift. And we know that the parent function is the most basic non-shifted function of that same type of function, right? So everybody look at these, and on your notes or on your whiteboard, anywhere you want, I want you to go through and write down what the parent function is for each of these, and then in words describe the shift. Now everybody stick with me today, and you're not going to have homework again. Just stick with me though. So I'm only going to write down the parent function and then just in words describe the shifts. So the parent function here would be the most basic non-shifted function would be square root of x. Did you get it right? Good. And in words describe the shift when I underline it. Right 2? Up 3. Very good. Here we go. The parent function here would be y is equal to x cubed. What's the shift here? Up 4. Shifts up and down. The sign stays the same. Up 4. And then right here, reflection over the x-axis. Good. Our parent function here would be the cube root of x. Right here is a left 1. Compression of a fourth. Reflection over the x-axis. Very good. My parent function here would be y equals x squared. Right, 5? Stretch of 2. You guys are doing awesome. Y is equal to the absolute value of x. Right here. Of 4. Compression of 1/2 and a reflection over x. Okay, I was glad to see a lot of you did not freak out on this one again. What was my parent function? Oh, but there was a few of you who had the wrong parent function. E to the x. You can't do plus 3 because that would be a shift. So this is our parent function. Our shift is left 3, down 5, stretch of 2, reflection over the x-axis. Okay, awesome. Way to go, guys. That was a review from last time. We'll be using transformations again today. Okay, what I want you to do is go to your pink worksheet, flip it on its side, find some blank room. There are not any problems like this on the worksheet, but there will be some on your test. And so we need to practice some. So multitask. Let's get this done in class again today. So notice, I want you to write down this somewhere on your pink really small and this one. You don't need to write down this one or this one. Write down these two. So while you're writing those down, I want you to notice something interesting. So I'm comparing the two functions. Now notice, in the first example that you're writing down, f of x is equal to the square root of 4x minus 4 plus 3, there is a 4 in front of x. Where in the other problem to the right of that, there's just the square root of x minus 4 plus 3, there's a 1 in front of x. Every time we've been doing transformations of functions so far, we've only had a 1 in front of x. In fact, you need it to be 1 in front of x to determine the correct shift. So in this first example where there's a 4, we cannot determine the shift right now. We have to fix that. So what we're going to do to fix this is we're going to say, okay, we need to get this to be a 1, so we're going to factor out a 4. Now when I say factor out, I don't mean pull it out of the radical. That would not make sense. It is under the radical. It has to stay under the radical. But we are going to factor it out of the term. So we're going to pull out a 4, divide by 4, divide by 4. So left in our parentheses would be x minus 1. Everybody sees? Then we still have plus 3 out here. Now we can split this apart. Because it's multiplication, it would be appropriate to split it apart. So we have the square root of 4 times the square root of x minus 1 plus 3. You see how these are equivalent? Well, now what's the square root of 4? So we have 2 square roots of x minus 1 plus 3. So now because we fixed that to be a 1, we can now determine the shift. And now we would be able to say right 1, up 3, stretch of 2. So from here on out, you just got to watch out. If there's not a 1 in front, fix it first. So over here, we're good to go. We'd say right 4, up 3. But down here, look, down here, we would notice there's an 8. So writing that one down. So now we would need to factor out an 8 here to make that a 1. Divide by 8, divide by 8. Left in our parentheses is x plus 2. Then we have minus 5 out here. We can split this apart. Cube root of 8 times cube root of x plus 2 minus 5. Cube root of 8 is 2. Cube roots of x plus 2 minus 5. And now we can determine our shift. Left 2, down 5, stretch of 2. Awesome. Okay, over here we're good to go. Left 2, down 5. Okay, what I want you to do is either on a whiteboard or on your paper, wherever you want, to answer these 4 questions. Find the shift from the parent function. Stick with me. I promise you're going to finish this in class again today. What do you think you'd do with it? Add, multiply, divide, subtract, what do you do? Check your first answer. Did you get this? Awesome. So you said right 4. I'm just going to abbreviate. Right 4, up 1, and then stretch of 4. Good. Okay, over here, you didn't have to fix anything. So you said left 3, stretch of 2, reflection over x. Right here, I was glad to see a lot of you did not let it throw you off. You knew I have to have 1 here. So even though it feels weird, I've got to pull out an 8. Divide by 8, divide by 8. So then left was x minus a half minus 5. So then you had 2 cube roots of x minus 1/2 minus 5. So then you'd say right 1/2, down 5, stretch of 2. You got it. A lot of you got it. Awesome. Okay, over here, what should I pull out? 4. So then divide by 4, left is. And then minus 3, square root of 4 is 2. Should I be multiplying it here? Yes. Right? There's not a magic addition sign. It was multiplied before, wasn't it? So we would have negative 6 square root of x plus 2 minus 3. Left 2, down 3, stretch of 6, reflection over the x-axis. Is everybody good with that? Okay, awesome. Okay, so it's up to you guys. Do you want a couple more examples of those types, or are you guys like, we get the picture, we'd rather just move on? Okay, cool. Okay, awesome. Let's begin today's lesson. So, we know that the shifting for all functions works the same. Shifts left and right have to be grouped in with x, you go opposite. Shifts up and down are added on the outside, the sign stays the same. A is a stretch or compression in the front, and a negative would be a reflection over the x, a negative in front. So without any examples, let's see if you can do this. Given the parent function y is equal to root x, write the new equation for the shifts of right 4, down 2, stretch of 5. Can you do that? Okay. Yep, on your whiteboard. 1, 2, 3. Ones that are having the issue are having the same issue on this one right here. We'll get to it. So check your answer here. You should have a y equals 5 square root of x minus 3 minus 2. Okay, awesome. Now what's happening over here is everybody, it's okay, but just pay close attention to what we're talking about. So it says a shift of left 5, that's got to be grouped in with x, right? Like that. The cube can't be right here though, or else that's not grouped in with x. The cube's out here. And then a reflection over the x-axis and a compression of 0.5. So y is equal to 1/2 and then a negative. Does that make sense? So you just got to be careful where you place that cube. Okay, awesome. Then right here you should have this. Y is equal to e to the x plus 7 minus 3. Is everybody good? Awesome. Way to go. Very good. Okay, cool. What I want you to do is problems 1 through 4 on your homework. Everybody back up here. So now what's going to happen is we're going to be given a picture of a graph and we're going to be asked to write the equation. So where you've got to start out is you've got to be able to recognize what kind of equation you're even dealing with. So right here I have a bunch of parent functions. So you've got to be able to recognize based on the shape of the graph what equation is going to match it. So this is a u. So we know we've been dealing with this for years. Isn't that an x squared graph? Okay, awesome. Now, so you'll have to remember that, but that one's pretty easy to remember. Now this sideways half u is a square root function. So if you see a half u, you would say that's a square root of x function, everybody. This is like what I call an upward facing snake. That is an x cubed function. Now this sideways, I call it a sideways facing snake or sideways s, a sideways snake is a cube root of x. So what I want you to notice, this kind of helps me remember it, to be honest. Notice both the roots are on their side. You see the roots on its side, the cube roots on its side? That kind of helps me remember. Yes. Yeah, it will actually, yeah. Well, you can, there are circle graphs, but we aren't dealing with them in this unit. Right here, I couldn't draw it perfectly. It should have been, but it was just my pen was having issues. This is a straight line. Straight lines are x. And then v's are what kind of function? Absolute value. So that's the first thing you've got to be able to recognize. Now, next thing, what I want you to notice, these are all the parent functions of each of these. There's one thing I call the special point. It's the origin. If we know this is our origin of our parent function, then if we take and start shifting this, like let's take this point and shift it right 4 up 2, and now it's there, and we have a new quadratic going up like this, don't we know the shift was right 4 up 2? We just locate the new point, the new special point. So everybody, you've got to recognize on a square root function, the special point is that. Does everybody see? So if I have the special point, if I have this drawn, where's my new special point? Right there. Does everybody see? So you'd say it was left 6 down 2. Everybody getting the picture here? The special point here is this middle point in between. Look, in between the point right here, which is symmetric with this point down here. It's the in-between point. And notice my cubic goes up first. All right, so then my special point here is that point. It's between the 2 points above it, like symmetrically placed. And notice the snake faces to the right first in the parent function. There's my special point, and there's my special point. So if those are shifted, we know the shift left and right. So here's my first example, just watch. So looking at this graph, the first thing that should go through your head is, what type of graph is this? A square root, right? Everybody, a half u. So you should say the parent function is root x. Now locate the special point. Boom. Isn't that it? So in words, we would say left 4, correct? And then up 1. So now let's put that in. We have the square root of x plus 4 plus 1. Now the next thing we need to check for, is there a stretch or a compression? So this is how you can tell. On the parent function, look back, on the parent function, the next point over was over 1 up 1. So what we're going to do is we're going to look over 1 and then see if it's up more than 1, or if it's, do you get what I'm saying? But it's over 1 up 1 still, so it didn't stretch out from the parent function. So it's still just a 1, so we don't need to write it. Okay? We'll do an example now with one that does have a stretch. Yes. Yeah. Yeah, it's a little bit more complicated, but yeah, in a sense. So let's look at this one. This one will help us out. Can I hurry and help you? Okay, awesome. So everybody, let's see, look at this one. What kind of function is it? It's a half u on its side, correct? So square root of x. So now we would say, where's the new special point? Boom, right there. So it was right 2 down 5. So we would say square root of x minus 2 minus 5. Now look, it's still, the parent function faces up. It's still going up, but it's over 1 up 2. It's actually stretched out 2 units. So now we have to put a 2 in front. Y equals, there it is. So it would be over 1 up like a half only. Does that make sense? If it was compressed, you always go over 1. And then look to see how high up or down. Look, over 1, stretched out 2 instead of 1. What's the question? Yes? Yes, so that would look like this. Like, it would have been over 1 only up a half. So then it would be compressed down. Like vertically, just pushing it down. So we always go over 1 and look how high up or down it went. Okay, let's look at another one. What kind of function is this one? It's an upward facing s, not a sideways one. X cubed, look, locate the special point, there it is. So in words, we would say that was left 4 up 3. So now you'll do this, x plus 4 cubed plus 3. Now look, is there a stretch or compression? If it's over 1 up 1, it's the same as the parent function. Isn't it over 1 up 1? And then it's not reflected because the s is going up first to the right, and so it wasn't a reflection over x. So that would be our answer. So it would be flipped. Yeah, so let's pretend this one would have looked like this. Do you see? If it would have been like this, guys, then it was reflected over the x-axis. Do you see? Okay, yes. Yes, you'll always look at the, you'll always go right 1, and then see if it went up higher or down lower than 1. So you'll see some more examples here, like this one. Look at this one. What kind of function is this? Cube root of x with a sideways s. Now find the new special point, which is right there. So it was right 2 up 3, correct? So you would go like this. The cube root of x minus 2 plus 3. Now we're always going to go over 1. The parent function would just be up 1, but it's over 1 up 2. So this is stretched out. So we have a 2 here. So there you go. Not that hard, right? Yes. The special point? You just got to kind of recognize where it was from the parent function. So on the cube root, it's the point in between the two symmetric points. Kind of like the point in the middle. Okay, so couple last one. Absolute value of x, not the last one, but almost. Right? Absolute value of x. So then it was left 4 up 3. So we'd go like this, x plus 4 plus 3. Now this one's flipped upside down, isn't it? So it needs to be negative in front. And then let's see, is there over 1 over 1? Down 1 over 1, down 1 over 1. So isn't this one a slope? So 1, we don't need to write, so negative though. Okay, cool. Okay, looking at this one. Find the special, well, first of all, once again, what kind of function is it? Cube root of x. There's my special point. Are you seeing it? Now, it was left 3, everybody. Any shifts up and down? Nope, so we have the cube root of x plus 3. And then let's look. Over 1 down 1, so no a, but the s usually faces like this. So it must be reflected, so negative. Everybody good with that? It's pretty dang easy. Cool. It wasn't, right? Because it was over 1, down 1 still. It just reflected. Okay, cool. All right, so the bell is going to ring for lunch, so we'll do this last one when you get back, and then I'll let you do your homework. Okay. I didn't say domain and range. Just let's hurry and quickly make sure we're good. Like, if you give me 2 more minutes, you're going to be working on your homework. So my domain is, where's your function growing from left to right? So from here it would be, yep, negative 4 to infinity. My range would be 1 to infinity. Good. Okay, look at my domain and range on this one. This was, my domain would have been 2 to infinity, and my range would have been negative 5 to infinity. All right, with this one, it was the pink one. So look, from left, it's growing forever, and to the right, it's growing forever, isn't it? And then isn't it growing down forever and up forever? So my domain and my range will be all real numbers. Or negative infinity to infinity. Same here, right? Isn't this one growing forever right and left? And forever up and down. Okay, cool. Now, domain here would be negative infinity to infinity. My range would be negative infinity up to 3. Okay, this is my last one. So everybody, you would say this is a what type of function? Square root of x. The special point was right 1 up 4. Square root of x minus 1 plus 4. Yep, and then it's reflected over the x, right? Because it's normally facing upwards. And then it's a stretch of 2, so negative 2. Domain would be 1 to infinity. Range would be negative infinity up to 4, right? Yep, because it's going down. Okay, do problems 5 through 8 and domain and range, ready to go. See what the work would be that I would expect. Inward, you'd go exactly right. 1 up 2, and then a reflection over x. Now, this is what you would do by hand. It used to be at the origin. A parent function starts at the origin. Our new starting point will be at this shift, right? So right 1 up 2. Now, from there, it would be appropriate to then type into your calculator in y equals that. And I want you to plot as many points that can fit on this graph perfectly as possible. So you're going to start at x equals 1, which we've already got graphed at 2, and plot, look at 2. Can 2 be graphed on here? Look at 3, 4, look at 0, negative 1. Does that make sense? It has to be a perfect graph. If the point can fit on here, it has to be on here. So type it into your calculator, give me some points. Over 2 up, what? 3 is negative 6, okay. So, but what's 2 at? 2 is at 1, 3 is at negative 6, and then 0 is at 3, and then negative 1 is at 10. So look, it's up here. Now, it makes sense. We know a cube is a S, right, that faces up. You've got to draw every point that can fit perfectly, so round it out nice and good. My domain would be negative infinity to infinity. My range would be negative infinity to infinity. Okay, so one more. You would say, okay, right 5, up 4, stretch of 2, and then a reflection over the x. Now, understand, guys, our graph, our starting point will only be affected by the right and the up. So we're going right 5, up 4. Now, for the other part, your calculator is going to take care of this stuff right here. Does that make sense? You don't have to worry about it. Like, your calculator will do it for you. It'll give you the appropriate points that fit those points, fit that stretch. So then from there, it's a sideways S. We know that. So give me some more points around 5. What's 6 at? 6 is at 2. And then what's 4 at? And then what is, I don't know, 2 at? Okay, so I'm not going to, what's the next whole number point? Anything? Scroll over here and see if any of these. Negative 3 up 8. Do you see how that fits on my graph? So I would go like this. Okay, drawing it in perfectly. And then it's coming down like that. Does that make sense? Domain, all real numbers. Range, all real numbers. So one thing to note, people always get thrown off when they see stuff like this. 2 plus the square root of x minus 5. Is that a 2 times? Is that a, what is it? What should I maybe do? Yeah, why don't we just rewrite it like this? Same thing, right? Okay, cross that out, same thing. So it's left 5 up 2. So just rewrite it in the prettiest format. I think we're good. We'd go like this. Right 5 up 2. You'd plot it in your calculator. It's going to look like this, everybody. Does that make sense? Okay. You have to have beautiful graphs. Finish the worksheet before you hand it in. Check it off with me.